Hello team, today's challenge is longest common substring, where we're given a string and expected to find the longest substring that is a duplicate. So in the case of abracadabra, we have abra at the start and abra at the end. Hello world, hello. Same thing, hello at the start, at the end. Mississippi, ISSI right here, ISSI overlapping. So overlaps are allowed. And then, of course, all these has, there would be 6 in the longest substring, right? Because 7 would be the whole string. That's not a substring. That's a whole string. So some interesting patterns here, but we can get it done. Now, there are a few different ways to do this, including something called a binary tree, which is some high-level stuff, right? That's way further than I prefer to take this one. Instead, what we're going to do is we're going to use something called sliding window. And the way that sliding window works is we are going to create basically a slice. Okay, if you can imagine it. In this case, we have a slice of 5 characters. So the window, these characters will never exist inside of our code, but to help you visualize, the window will be 5 characters. So it will be hello. And then we will shift the window, or if it helps you, shift your perspective, right? Which gives you a different 5 characters and a different 5 characters. And you keep doing that and capturing these and testing against them until you get to the last 5 characters. And hopefully by then, or hopefully before then, you've found a match, at which point you found your longest substring. Okay. This should hopefully make sense once we actually get into the code. So let's do that. Now I'm going to use length a lot. Okay, I'm going to use it in a few different places, and I don't want to be typing string.length repeatedly, so I'm going to capture that into a variable. And then from here, I'm going to set up my first loop. Okay, so this is going to be let I equal length minus 1. Why length minus 1? Well, because we don't care about the whole string. We only care about a part of the string. And this I is a length, right? We can't test against all 17 characters in hello world hello. Instead, we only test against 16 characters, and we shift the window. Okay, so length minus 1, and then from there we go I is greater than 0. Is that right? Yes, greater than 0, and I minus minus. Okay, so we are constantly making that length or the number of characters inside of the window less and less. Okay. From here, we set up a capture. So found is going to be an array, and we're going to toss these words into there so that we have something to test against every single time. Okay. From here, we enter our second loop, and our second loop slides the window. Okay. It allows us to iterate on just the number of characters, whatever this I is, this length, and send that to found, or if we did find it, return it, right? That's what we're going for here. So this is going to be j, okay? And we're going to set that equal to 0. And then from here, j is going to be less than equal to, what is it? Length minus 1, length minus I, not length minus 1, but length minus I. I'll explain that in a bit too. Hopefully it'll make sense once we get through this. And then of course j plus plus, because this is iterating over indexes. Okay, the I is a length, the j is an index, so we're going to use it that way. Okay, in fact we're going to use it that way right now. So the substring is string.slice. You could also use substring here, right? The actual substring method with exactly the same arguments gives you kind of the same result. But I'm going to stick with slice because I know it. Okay. But we start at j. So j is 0, j is whatever it is. And we go to j plus I. Okay. J plus I. That's important because remember that I is a length, not an index. Okay. Not an index. Now, if found dot includes that substring, then we found it, right? Because we started with a really long string and we've been reducing it down. So in theory, this is the longest substring that we have, or at least the first longest substring, right? If there were multiple equal substrings, this would be the first, okay? So we're going to do that. We're going to return substring, okay? Otherwise, we are going to push. So found push substring, and that should do it. Now, this right here, this second return doesn't do anything for us, but we probably should return something, right? So let's return an empty string, right? This is to say we went through all this work for basically nothing because there are no duplicates, which means that we get an empty string. Could we throw an error or something? Yeah, but empty string feels about right, okay? And that's it, right? It works. Again, we don't really have a test for this one. This is just safeguarding the return, okay? The question becomes, how does it work, right? I kind of explained it up here with the sliding window imagery, but let's actually take it and work through it. So right here, I'm going to paste in abracadabra. Abracadabra has 11 characters, so that's going to be our length, okay? Our length is abracadabra, which means that our I is going to be 10, okay? Length minus 1 is 10. Brilliant. And remember that that is the number of characters in the window. So now there are 10 characters here and 10 characters here. Great. So with that, how do we slide the window? Well, that's what our second loop is for, right? We set it to 0, which is an index. That starts right at the beginning of the string, the A, the very first A. And we shift. How many iterations do we do? Well, we can only really do 2. So what we do here is we use this math to be sure that we can only ever do 2. And that is length minus I. 11 minus 10 is 1. So we need this to go from 0 to 1, which is 0. And this B is index 1. Okay. If we don't find anything in there, so we go to the next one. We reduce down to 9. 11 minus 9 is 2, right? So we would go 0, 1, 2, which is exactly what we have. We have index 0, index 1, and index 2. And we keep doing that. So 11 minus 8 is 3. That's A to the B to the R to another A, right? And we keep building out these strings. All these strings get added to found. And then if we don't find anything, we get rid of them and we start again, okay? Until we get down to iteration 4, because we're going backwards, right? So 11 minus 4 is 7, which means that we should have 7 items in here. 1, 2, 3, 4, 5, 6, 7. No, sorry. 0 indexed. So 0, 1, 2, 3, 4, 5, 6, 7, right? Doing it right. And each one of those has 4 characters, which is exactly right. Now, the key here is that as we go through, unfortunately, because of bad luck, it appears in the very last spot. Kind of a interesting example, but if you do the same thing with Mississippi, you'll find that it exits sooner, okay? But we go through and we find 4 letters, and then we find the next set of 4 letters and the next set of 4 letters, right? Until we get to this, and because of our if, we go, did we already see this one? Well, we absolutely did. It was technically right at the start, but there it is. So we return that as our substring, okay? Otherwise, we just keep going until the end. So the only real problem with this then is that it's not super fast, right? And the reason that it's not super fast is because of this, right? This double loop here. As soon as we get into the smaller numbers, we need to do more iterations, right? We only did 2 iterations for the first pass, 3 for the second, 4 for the fourth, for the third, right? And then what was it? 7, 8 for iteration for length 4 when I equals 4, right? So every time the number of loops that we need to do grows, which can make this terribly slow, right? Again, if we were very serious about performance here, then maybe a binary tree would be faster. I don't know, right? That's a lot of extra work that I haven't really explored, right? But it does get the job done, right? And I'm not even sure when I would do this in real life. Maybe passwords. That's the only real example that I can think of for testing to make sure that we don't have repeating characters inside of our password. If you can think of other examples, hit me up in the comments. Sorry, hit me up in the comments. Also, let me know what you think of all this. If it makes sense to you, if it doesn't, right? If you like it, if you hate it, if you found a different way, let me know all that stuff in the comments. Otherwise, today this has been Longest Common String, and I will see you tomorrow.